All right, Maddie, you've got some tough little problems here. So I ran through and just looked at the ones you hadn't filled out yet, and did check the ones you had completed. And so, like, your number one looked great, and your number two, uh, I love the 25 on the right-hand side, but I know it's not going to be answer one here, and I know that because this circle is centered at the origin. So if it's centered at the origin, if you think about the equation of a circle, it's x minus the h. How much is the x shifted plus y minus the k? How much is the y shifted equals your radius squared. And so if your centers of the origin, then you aren't shifted left or right at all. And so your h is like 0 and your k is 0. And so this simplifies to just x squared plus y squared equals your radius squared. Um, and so let's talk about where this 25 comes from. In this case, the 25 comes from the fact that this circle is centered right here at the origin. And this circle also goes to the point -3 and 4. This point right there. And so this is your radius, that R. And your circle is sitting right here, like so. And so this 25 must be how long this R is. It must be 5 units long. Remember, this is R squared here. So if R is 5, then you get 25. So where does that 5 come from? Well, when I drew the picture here, I draw this intentionally because this right here, this radius, is can be broken into a right triangle right here. So here's the right triangle it can be broken into. I'll highlight that in a green here so it kind of stands out a bit more. So there's the triangle, and this triangle has certain side lengths, and I know what they are because it's got an x value of -3 right up here. That means that's 3 units long, and it's got a y value of 4 or height of 4. That's how tall it is. And so this triangle, you can figure out the radius by doing a squared plus b squared equals c squared. And so that's 9 plus 16, 25 equals c squared. And you could square root that and find out how long that side is. But you have to square it to put it in this equation anyway. So that's your r squared. Our r squared is this c squared. R squared or c squared is 25. And we're going to have to use this idea where we go, hey, here's the center of the circle. Here's where it meets the edge of the circle. We should be able to calculate that radius. So that's a frequent move when we're dealing with circles. Oops, I'm gonna move all of that. Okay, so your 3 looked good, your 4 looked good, and that looks like you left 5 blank here. So let's talk about this guy. Which of the following equations would fail to have solutions? So we want no solutions, essentially, is what this problem is asking us. Which equation has no solutions? Well, one thing we should have learned, or we do know about absolute values, is that no matter what number is in here, when I take the absolute value of it, I always get a positive answer. All right, so if this number in here is -7, and I take the absolute value of it, it's 7, no matter what. So if I have an absolute value and it ever equals a negative number, it is impossible because that just does not happen. Absolute value means, they probably talk about how far something is away from zero. And when you measure something, you don't say, hey, it's -7 units away from zero. No, you just say it's 7 feet or however you're measuring your distance in. So absolute values are always positive, and that tells us how to solve these. What you do is you just get your absolute value alone and make sure it equals a positive number. If it doesn't, then it's an impossible situation. So like this one, we go -1, -1, 6, absolute value of x equals 16. And when I divide by 6, I'm going to have a positive answer. So that's okay. Okay, that one will give me some solutions. This one I subtract 7 and I get a 4. So I got an absolute value and it equals a positive number, and that is okay. Right here, though, I'm looking at number 4. I subtract the 4 from both sides. Nope. I get a -3, but I still have this negative out front. So I'd have to divide by a -1. I thought it was going to be this guy, and I get the absolute value is 3, and that's okay. So I hope it's this C or number 3 here. I subtract 10, subtract 10. Ooh, I get a -5 on that right side. And yeah, it's going to stay negative because my next step would be get rid of this half. So I'd multiply by 2 because 2 times a half is 1 and multiply by 2. And so when I get done here, I have this absolute value x plus 8 equals, and -5 times 2 is -10. And that is not possible. Can't happen, no matter what that x is. I could make that x really, really, really big and negative, but it would still always come out to some positive number. And so it's never going to equal that. So your answer here is that number 3. Okay, absolute values can never equal negative. There's a few problems like this that you'll see sometimes. One is like absolute value of x equals -4. Okay, it doesn't matter that this is a 4. What matters, this is a negative. And then you go, "Oh, okay, so this one has no solutions." Another one they throw at is the inequality. When is the absolute value of something greater than 0? And this one is like all real numbers because anybody you plug in here is going to turn into a positive number. Okay. There is one exception though, because this says just greater than 0. It's all real numbers except 0. Okay, because if you plugged in a 0, 0 is not bigger than 0. But like if I plug in -5, absolute value of that is +5, which is bigger than 0. So if you ever see this or this, where they do have the included equal 0, that's just all real numbers, including the 0, because that would still make it true. And then another inequality they throw at you sometimes is this guy, absolute value of x is less than 0. And that's no solutions because no matter what you plug in here, it's going to be a positive number, except again, 0, because if I plug in 0, it's not less than 0. Oh, gosh, this is no solution. So yeah, nothing works for this guy. But this one, has one solution. When they put the little equal sign, it does have 0 for an answer because 0 makes it equal 0, but nothing else makes it less than 0. So those are just little trick questions kind of that they test you with to see if you understand the concept of what's going on. All right, enough about that stuff. Let's see here. Over here, we got to look at number 6. And it kind of ties into what we were just talking about. It says, hey, the distance has to be less than 8 units away. Okay, so if we think about this on a number line, and we got some x here, um, and we don't know what it is, but we know distance from it is less than 8. So that kind of pins us down. 2, 3, 4, 5, 6, 7, 8. I could be over here, 6, 7, 8 over here. So if I'm here or here, I'm exactly 8 units away from the x, right there and right there. But the problem says, when is my distance from x less than 8 units? Well, if this is exactly 8, then less than 8 are these points in here. And so if I'm going to describe these points right in here, I'd say, hey, I want the numbers here that are less than, oops, not less than, greater than a -8. Because if I'm greater than this -8 over here, then my distance from this number I don't know, x, is less than 8. Right? And then if my number is over here, uh, this distance here, this is exactly 8 units away. This is 7, 6 units away, 5. These are the distances that are less than 8 units away. So to describe that section, I'd say, hey, I want the x's that are less than 8. So when I sum this up, I'm looking for one that says, hey, the x's have to be bigger than a -8. The reason this works this way is because, like, if I want to be bigger than a negative number, I actually have to go to the right, and that gets me closer and closer to the x, making my distance smaller than 8 units away, but making the description of the number as x's are bigger than this -8. Less than -8 would put me out here like -10, -15, -20. I don't want to be that far away. I want to be less than 8 units away. Okay, so x is greater than -8. So if I read from x's point of view, this says x is bigger than, always the crocodile points to the small one. This is the big guy. So x is bigger than the -8. X is bigger than the -8. So that one's right. And x is less than +8. X is less than +8. This is answer one right here. Okay, yours says x's are less than -8. So you answered this and this set of numbers, and those numbers, like number -9 is out here, that's more than. So you answered this question. Show me all the x's that are more than 8 units away. So hopefully that explains that a little bit. Let's see here. Number 7, you did just fine. Number 7 is kind of like how you answered this one incorrectly, but this time it works because see, this one says, "Hey, I want to be more than 5 units away." So, I don't know what x plus 2 is here, but I got to be, uh, here's 5 units away, and here's also 5 units away. And I want to be more than, greater than the 5 units away. That means I want things that are out here and I want things that are out here. Those, if this is where I'm measuring from, these points are more than 5 units away from this position. Okay. And so to describe this, that's the answer you chose, but it's the x's that are smaller than the -5 and x's that are greater than the +5 and equal to because of that equal to symbol right there. All right. So that one you did just fine on. Now let's look at how we can solve these things straight away. So the key thing is this first step that I always tell students, get the absolute value alone. So let's talk about what it means for an absolute value to be alone. Okay, there's an absolute value. Here's an absolute value. So this is not considered alone because it has a 2 in front of it. This is 2 connected times that absolute value. This is not considered alone. And what we mean is, so we got these equations, and so we got to make sure that the absolute value when we're solving these problems is by itself. So if I look at the equation you have, here's my absolute value. Let's highlight him here. So this little chunk is what I want to get by itself. And so, it's just like solving some equation like 3a minus 2 equals 16. The a is my absolute value. And I'm just trying to get the a by itself. So if I was solving for a, I'd add 2 to both sides. And then I would divide by the 3 there to get the a by itself. And so I'm just kind of treating this absolute value like that a. And I go, well, to get it alone, I would add 2 to both sides. Give me 3 times the absolute value. And I can't have that 3 in front of it, so I divide by 3, just like I would if that was just an A there. So there we go. Now my absolute value is alone. Then once you do that, you have to write 2 equations because see, there's 2 possibilities to this thing. This thing equals 6. That means not the absolute values. I'm not going to highlight the absolute value. I'm going to highlight the stuff inside there. That means whatever x is, this stuff, the x plus 4, it has to either equal a 6 because the absolute value of 6 is 6, or the stuff in here could equal a -6 because when I take the absolute value of a -6, I get 6. So all we do is we write down those 2 possibilities. We just say, hey, that x plus 4 inside the absolute value, it's going to be either a +6 or that x plus 4 inside the absolute values, it might be equal to a -6, but it's going to be equal to one of those because when I absolute value it, it has to give me that +6. And then we just have these little mini equations to solve. We subtract our 4, we subtract our 4. Be careful, it's the same operation, but different answers because you get -6 minus 4. Okay, so those are the 2 numbers, and you can see them really working here. We'll work them in this one. You can put them in that one as well if you want, but it's easier with the small one. 2 plus 4 is 6. The absolute value of 6 is 6. Plug in a -10. -10 plus 4 is -6. Absolute value is 6. So they both check. All right. Don't confuse this, negative 10 like we're getting a negative 10. No, we can put negatives into absolute values just fine. We just always get positive answers out of them. And then let's see here. Number nine is just a doozy of an equation. So first off, I'd like to point this out. You could, here's the cheat for it. Grab your Desmos calculator or whatever calculator you have, just get good with it. You could type in your equation like this. And you know how to do this. I should have pre-done this. It's all right. Fast forward through it. There we go. And so you could graph this thing. It's not super easy. I was hoping it'd like give me a point in the middle where I could just say, hey, my center is right here. Um, but if we look at this thing, and I'm going to take a snapshot of it so I can draw on it. And we'll shrink that thing down just a little bit. There we go. And I'm going to put him right on my paper here. All right. So here's my circle that I've got on Desmos. I'm gonna do that. There we go. There's my circle. And so I could eyeball this thing and probably figure out where its center is. It looks like it's right about there, but we'd have to measure this. So we'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So its diameter is 10, which means I just want to come down 5, 2, 3, 4, and 5. Oops, 1, 2, 3, 4, 5. There we go. So there's the middle. And I got to check it from this side too. 1, 2, 3, 4, 5. Yeah, so that's dead center of this circle. And now I know his center. It's at 1, 2, 3, and down 1, -1. That's the center of the circle. Okay. And so at this point, I know everything I need to know about this circle, and I could write his equation. Remember, I just measured his radius was 5. So here's the equation. It's the center of your circle, by the way, maybe this will help out too. We usually give the symbols H and K. And so the center of this circle is 3, -1. That's your H, that's your K. And the circle's model is X minus H quantity squared plus Y minus K quantity squared equals your radius squared. So I go X minus, I stick in my H, which is 3, a Y minus, I stick in my K, which is -1, and I put in my radius, which is 5, but I got to square it. And so I can do just a little bit of cleanup, not with the X minus 3, that one's fine. Here we get this double negative, so we usually then rewrite it as a positive, and we usually square that. So there we go. That's the equation of the circle. Now, without Desmos, a little bit trickier. Okay, what we do is we group the first pair, we group the second pair. We're grouping our x squared and our x term, our y squared and our y term together. Uh, you want to always make sure there's a plus sign. So if this was like x squared minus 12x minus y squared plus 4y plus 60, if it was that or equals 60, I'd group it this way. I always have to have a plus sign between them to start off with. And then I go negative y squared, and I keep the sign as 4y like this. Okay, so I'm capturing the two terms in that case together like so and putting that plus in the middle if you got a minus sign. In the problem you have, there is no minus sign, so you just capture it this way. That gives us the plus, and we don't have to have a plus in front of this because we already know it is positive when there's no sign. So I group it like this. And truth be told, we've done one like this before, and I said, hey, kind of write it this way, plus some blank, because we're going to add a number here. We're going to complete the square on this. And we got to complete the square on this one as well. And then we've got this 60 over here. That's on the right-hand side. And we're going to have to compensate for what we add here. We're going to have to add to the other side of the equation. And what we add in that spot, we'll have to add here. All right. Now, hopefully it's this easy and you get a nice simple one, which I think you will. It'll have these just nice 1x squares. And so it's a pretty easy process. All you got to do is get what I call the magic number, And all you gotta do for the magic number is get your b value, divide it by 2, and square it. So b, remember, is the coefficient of the linear term, the term to the first power. And so in this one's, it's in the first equation, it's a 12. In the second equation, it's the 4. So I'm going to find this magic number. I'm going to take that 12, I'm going to divide it by 2, and I'm going to square it. So 6 divided by, or 12 divided by 2 is 6. 6 squared is 36. And I'm going to add that 36 right there. And I'm going to then, over on the right side of my equation, add 36. Alrighty, this is not looking good for what I predicted for my circle. And I just realized why. So I'm realizing this is getting a radius. It's way bigger than what I have going here in my drawing. And here's why. I forgot to look at my scaling. I said this was out here at 5, but it's not at 5. This thing's counting by twos. When I was trying to redraw it to get it into my, take a picture of it, I goofed up my scaling. So this is like a 10 right here. And my radius is not 5, my radius is 10. And so 10 squared is 100. So I'm going to end up with 100 on this. And this is not x minus 3. I got to double that 3. That's going to end up being a 6. And same with my y value. It's at -1, but it's not going to be at -1. It's going to be like at -6, I think, or something also. Let's find out. Anyway, I know I've screwed up my little picture there. Um, so let's go find this magic number now. I do the same thing. I take the b term, which is a 4, I divide it by 2, and I square that. That's 2, and I square the 2, and that's a 4. I'm going to add a 4 here, and I got to add a 4 onto the right side of the equation. Okay, so there's the magic number, right? And so if you don't know or don't remember why it's so magical, here I will show you. What it's done is made this a perfect square. In other words, I can factor him now, and I already know how he factors x and x, and I guarantee all you got to do is square root that thing, and that tells you what goes there and there. 6 times 6, and then they got to add up to the middle term, so they're both negatives. Okay, so that's how it factors, but more importantly, it can now be written this way. And so this is going to be a circle that is shifted right by 6. And so, normally our circle is right there. It's been shifted this way, not by 3 units like I thought, but twice, 2, 4, 6 units to the right. And so this is the correct first section of the equation. Second equation, again, it's a perfect square now, so I already know it's going to factor just great. I just go y and y, and square root of 4 is 2, or 2 times 2 is 4. But it is always going to be just square root it in 2 and 2. And then this time they add up to a plus 4, so they're both positives. And so that can be rewritten as y plus a 2 quantity squared. So this is now a shift down, sorry, because this is our y by 2. So again, I had it shifted down by 1 right here, but I should have been counting by 2, so it shifted down by 2. And then finally, it equals the right side, so I got to add up all that stuff. Well, there's 60 plus 36, that's 96 plus 4. Yeah, 100. Well, shoot, I goofed up my graphing method, but it would work if I could learn to count. But there's your equation. By using the magic number to complete the square, start with just group the first two, group the second two, leave a little space in there for that third term that you're going to get. All right, then find the equation of circle in center radius form, whose center is at -5, 8. So that's your HK. Love it, because x minus h squared plus y minus k squared equals your radius squared. And so x, careful here, it's minus because of the formula, but then it's -5 because that's what h is. And y minus k is an 8. Don't have to worry about the negative there. I do not know my radius yet. We'll find that out in a little bit. But that's all I got to figure out for right now. There we go. Multiple choice, at least we'd have it really narrowed down at this point. Okay, so let's go ahead and find R. Um, R essentially is what we've done before. We had a beautiful triangle last time, whose center is at negative 5, 8. So I'm just going to estimate where negative 5, 8 is for you. And I'm going to call this negative 5. I'm going to call this 8. Okay, so there's the center of the circle. And then I know I go through this point that's at 2, and I'm going to put 11 up here. 11. So that's 2, 11. And I know my circle goes through this. That means that that's the center, and that's the edge of my circle, because that circle is right. I know right where it's at now. Let's grab a pink here. It sits right here. And so this is the radius from the center of that circle to that point. And so I just have to know how long he is. Well, let's draw a little triangle for him, right? When you draw this little triangle, you have your radius, just go horizontal, just stay even with the x-axis until you get even to your point. Now I'm even with him. And then go from your point, drop straight down parallel to the vertical axis. And that gets you your triangle. So we're just trying to figure out, we'll have to use the Pythagorean theorem again, that a squared plus b squared equals c squared, right? But we can just find the sides of these triangles. We could also use the distance formula here, but this is kind of a fun way to do it. So this x value is at negative 5. This x value right here is at 2. So from negative 5 to 2, that's a distance of 7. So this is 7 units long, okay? Now let's check out the height of it. It goes up to 11, but at this point, you can't read it, but that's an 8. So this distance here is even with the 8. It goes up to an 11. So 8 to 11, this thing must be 3 tall. So I've got a triangle, and it's a right triangle because x and y's are perpendicular right there. And it's 7 long and 3 tall. So a squared plus b squared equals, and I'm going to call it r squared because that's my radius. Now I'll just go 3 squared, doesn't matter which one I call a, doesn't matter which one I call b. 9 plus 49, and 9 plus 49 is what? 58 equals r squared. Great. I don't even have to square root it. I just write, hey, that side of the equation is 58. Okay, so that's how you do it with the little triangles. Your teacher may not do it that way. They may pull out the distance formula. Find the distance between the x's, square them. Find the distance between the y's and square them. Okay. I do want you to see this since you sat through how I did it with my little triangle thing. Watch this. It doesn't matter which points are x1 and y1 or x2 and y2. What does matter is whichever point you call x1 has to be paired with the y1. And whatever you call x2 should be paired with the y2. This is like, hey, I'm x for point 1. Oh, I'm y for point 1. I'm x for point 2. I'm y for point 2. So this is my point 2, and its coordinates, its x coordinate gets a subscript 2. And that's because I just decided to call it point 2. All right. Uh, so now I can just use this little formula. So watch how this works. D equals the square root of, and I take my x2, negative 5, and I subtract my x1, 2. By the way, that gives you a 7, actually negative 7. That's how long this is. That's all that does is calculate this distance right there. But we can do it by looking at a picture. Okay. Um, so that's going to turn to just a negative 7 squared. Okay, then I go plus. Now I got to do my y subtraction. So I go y2, which is 8. And I subtract off y1, which is 11. Oh my goodness, 8 minus 11 is a negative 3. And I square it. Yeah, it's 3 long. That's how tall this triangle is. That's all the distance formula does, is it finds the distance between those 2 points in a triangle. So I square my 7 there, my negative 7, but it becomes positive. I square my 8, or 3 rather, negative 3, but it comes positive 9, negative 3 times negative 3, and I get the square root of 58. And that's my r. That's the distance between the center of the circle and the point. But I want r squared, which is then 58. And so you can see we get the exact same result. All right, there we go. And just a few on this side, I think. I don't know why I didn't circle the rest of these things. Huh. Um, Solve for all values of x. So absolute value equation. So if you remember, I said get the darn absolute value alone. Excellent. We add 9 to both sides. X plus 3 is 2x plus 9. I have to leave them separate. They aren't like terms. All righty, so here we go. This is a tough little math problem. I will tell you the procedures for it. Step one, isolate the absolute value. That's always the same thing. Um, Boy, let me think which way is easier for students. This probably would make the most sense. Okay. We'll do it exactly the same way we did the last time. All right. Again, uh, this stuff in here might be, no, I can't do it that way. Yeah, we do it that way. So this stuff in here could be, again, a positive number or a negative. And whatever it is, it's got to equal 2x plus 9 when we get done. We just write down both possibilities. We say, maybe x plus 3 doesn't really need the absolute value taken of it. Maybe it's already a positive some number. But whatever it is, it's still got to equal 2x plus 9. And so really without the absolute values, if this comes out to be a positive number, I really didn't need the absolute values, right? But this maybe is a negative. Maybe it's the opposite of what I just thought this was. Instead of coming out to some positive number, it comes out to the negative of that. And so here's how we write that possibility. We say, hey, the opposite of x plus 3 could also equal 2x plus 9, right? And when you take the absolute value of this thing, this would just disappear. And so without the absolute values, we can write this and say, hey, this could also be true. Either the x plus 3 without absolute values is 2x plus 9, or if x plus 3 is a negative number, I need the opposite of it so that it is positive and it still equals 2x plus 9. Okay? Hopefully that explains it to you. But all you got to do is isolate it, drop the absolute values, and rewrite the equation. Then replace the absolute value with parentheses and put a minus sign. There's a couple of different ways to solve this one. This is the way I decided to explain it. If your teacher tells you a different way, go for it. Okay. Now these are just linear equations, though, because I don't have absolute values in them anymore. So we're going to get the x's on the same side. I'm going x's to the right, and I'm going to move constants to the other side. Right? We can do those steps at the same time rather than one right after the other. So on this side, these cancel, giving me -6. On the right side, those cancel, and 2 minus 1 is 1x. So x is -6. And over here on my second equation, you could distribute the negative or you can divide both sides by a negative. I'm going to go ahead and distribute. And now I'm going to, so I just did -1 times both. And then I'm going to get my x's on the same side. So I'm going to add my x here because that'll eliminate it and add it over there. And I'm going to move my 9 from this side, put it over there. So basically the same two steps. So -12, though, this time equals 3x, and I divide by 3. So x could be a -4. Okay, so those are our answers. Let's go ahead and check those. Okay, so you can see them check. Once in a while, you get extraneous solutions when you do a problem like this. So here we go. Absolute value of -6 plus 3. I'm testing this first answer here. Does it equal 2 times -6 plus 9? Right? We just replace x with what we think it could be. See, on the left side, I get -3. Absolute value of -3 is 3. On the right side, I get 2 times -6 plus 9, -3. They did not work. -6 is not a solution, even though our math said it was. All right, let's check the other solution now. -4. So I'd go absolute value of -4 plus 3. Does it equal question mark? 2 times -4 plus 9. So -4 plus 3 is -1. and the absolute value is 1. Does that equal 2 times -4 is -8 plus 9 is 1? Yes. So there's your one solution. Now, real quick, if they give you a calculator for this thing, here's how I would solve it. I would again, well, I don't even know if I would take the 9 over, right? If you give me a calculator to solve this equation, and you can do this with a graphing calculator or with Desmos, but I would simply graph the left side, x plus 3, and the absolute value, um, minus 9. So there's the first equation. Then I'd graph, or the left side of the equation. Then I'd graph the right side of the equation, right? So, to be a little more official, maybe I should go something like, I don't want to shortchange it here. So just y equals, there's my first equation. And then y equals, that's my second equation. So I make this side y1 or y, and I make this side a second equation. And then I just look where they cross each other, right? They cross right there when the x is -4. And that's the answer I have. The -8 is just telling me what happens when I plug a -4 into this side. When I plug a -4 into this side, it becomes 8, or -8 rather. And when I plug a -4 into this side, it becomes -8. So as long as I plug in -4 to each side, it makes it true, and that's my answer. So quick way to solve any equation. Graph the left side, graph the right side, see where they intersect. That's a little cheat that can take you a long way as long as you got Desmos or a graphing calculator. In the XY plane above, I'm on number 12 here now. Ooh, seems like I've been recording twice on this machine. In the XY plane above, the circle has center at HK. Boom, there it is. And a radius of 10. Awesome. So I know this is 10 units right there. What is the value of K? La, 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 la. Um, I wonder. I'm just playing with this drawing to see if there's a quick way to solve this thing. I'm just playing with this 10. And so, does that tell me anything? I'm not sure. I'm trying to find a quick way to solve this thing without doing the brute force method. I'll show you the brute force method, and I don't, man, can I assume? I guess the thing I'm troubled with right now is that's isosceles. That has to bisect it. And no matter where that circle was, I could draw this image. So I think that's 10 and 10. This whole distance here is 16, which means this is 8 units and this is 8 units. And so if this is 4, and if I add 8 to it, this K, no, not the K, the H must be at 12. I just need to figure out how tall this triangle is, it looks like. And that would tell me my K value. And I can figure that out pretty easy because this is the triangle we have here. We got this triangle. Yeah, this would be the quick way to do it. And you can tell because of the geometry that this is an 8 and this is a 5. And so now I could use the Pythagorean theorem. Okay. Or if you remember back in your geometry days, you had this 3, 4, oops, this isn't 5, sorry, this is 10. You used to have these 3, 4, 5 triangles. They were Pythagorean triple triangles. 3 squared plus 4 squared equals 5 squared. This is 9 plus 16, 25 equals 25. Well, if I took this side times 2, this side times 2, and this side times 2, this would be the same triangle, just bigger. So 6, 8, 4. So if this is 8 and this is 10, this is, or 6, 8, 10 rather, uh, this would be the 6. So I know it's 6 units tall, and I could then tell my K is 6. Okay. So that's one way to do it. I'm going to show you the brute force way now, and it might be the way they want it, but I'm guessing no. So you could write this equation here. I could use that distance formula I talked about before, or that we used before. X2 minus x1 squared plus y2 minus y1 squared. And the blue line and the red line are both radiuses, so they have to equal each other. And so I could write, man, there's no way he wants you to do this. He wants you to do that little drawing that I showed you before. So I would use the little drawing. I'm going to call this x1 and y1, and this one x2 and y2, 2 and y2. If we were doing it with the long method here, you'd go x2h minus x1 4 plus y2 minus y1 squared. That gets you the distance in blue. And then if I did the other one, I'd call this one x1 and this one a y1 this time. And I'd write the formula, oops, jumped pages there, d equals, and again, I'd go h minus the x value, 20, squared, plus y, or k, minus the y1, 0, squared. And those two equations have to both equal 10, so they have to equal each other. And if they equal each other, trying to think though, I get two equations. That's not an h, or y over 2. That's a k. Yeah, but oh, but those are 10, so I know they're equal. I'm playing with the idea of how you would solve this quickly. I know these things have to be equal to each other. Yeah, I can't think of a quick way to do it. These are 10 and 10, so you can separate this triangle like this, and then you know that this thing is half of this total 16, so that's 8. And so there's your triangle. It's 8 and 10. You're looking for this guy right there. You could do a squared plus b squared equals c squared at that point. So r squared equals, that's 100. That's 64. You subtract it. So r squared equals that 36, so R is 6 that way. Okay, but again, it's a 3, 4, 5 triangle that's been doubled on all sides. If I think of, there's something I'm missing on that, just not coming to my head right now. 13, find the equation of the circle whose diameter has endpoints at the ordered pair 0, 0, and 1, 2, 3, 4, 5, 6. 4, 5, 6, 7, 8. That's terrible. We'll try and scale this thing a little bit better. I think I've been teaching too long today, Maddie. Okay, so I'll do my 8 first. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So right there is one whose diameter has endpoints. So, and 0, 0. So this is the diameter of the circle. Diameters have to go through the center of a circle. So the center of the circle is right there at that pink dot. I just got to find him. Now I know this point is at 6 on the X. And so halfway would be 3. And I know that this thing is on 8 on the Y. So halfway would be 4. So this circle is X3 and y4 for its center. Just cut the x in half, cut the y in half, because it's centered at the origin. Find the equation of the circle whose diameter has those endpoints. So now I've almost got my circle. So my circle center is 3, 4, so that's hk. So it's x minus h, quantity squared, plus y minus k, 4, quantity squared, equals my radius. So My radius now is one of these. It'd be like this distance here, or you could use this distance here. I'm actually going to use this one right here because I think it'll make more sense to you. If you notice, even when I was trying to figure out the center of the circle, I drew a little triangle right here. I'm gonna blow that up so we can look inside that triangle. So there's the center of my circle. In fact, let me draw this circle in here so you can see it. Do it in yellow. It looks like that. So that's my center. I need to know its radius. But I just figured out this dimension here on this triangle is 3, and this height here is 4. This is one of those 3, 4, 5 triangles. And so I know my radius is 5, and so radius squared, 5 squared is 25. And now you've got your circle figured out. Tough problem. Solve the inequalities shown below. Represent your solution both in set builder notation. Not sure what you guys are calling set builder notation, but I think it's this notation that you use, something like that. And on a number line. Great. Absolute value equation, if you remember, isolate the absolute value, right? So we're just treating this like one quantity, leaving it by itself, subtracting first, and then we're going to have to divide away that 3 here. So divide the left by 3, the 3 is gone. Divide the right by 3, get 6. All right, so um, I'll show you 2 ways to solve it. First, I'll solve it. Uh, mm, Now, I won't solve it graphically for you. No, I won't solve it with the calculator either. I just show you the 2 ways. Got it written alone? Great. Here's the logic you use. You say, hey, x plus 4. If you're a positive number, great. I don't have to take your absolute value. You're already positive. I just got to make sure you are less than or equal to 6. But if you're the opposite of that, since I want to be, think about it again, I want to be less than 6 units away from, let's just call it the origin here. I want to be less than 6 units away, puts me this way. But over here at -6, the opposite, I want to be bigger than that. So I want the opposite of this thing to be. Yeah, let's not do it that way. Wish I could rewind this thing and erase it without having to do all the editing, Maddie. And I can't do that. So I'm going to explain this a different way. And I'll just give you the rules to follow. Okay. So you got your absolute value isolated. And we almost do it exactly the same way we do it when it's an equal sign here. Again, just drop your absolute values. It could be positive. And so say, hey, x plus 4, maybe you're already a positive number. I just need you less than the 6. And then you write it again, x plus 4, just like you're writing the same equation again. But you're going to have to flip the inequality. Okay, so you got to do a flip and you've got to do a change. You got to make it a -6. And what essentially this does is your x plus 4 has to be, if you want to be less than 6 units away from something, you've got to be less than the 6, but you've got to be greater again than the -6, because that's what gets you closer to the stuff in the inside. So you want to be less than 6 units away or greater than 6, or greater than -6, less than 6. So there's the less than 6, there's the greater than -6. Flip and change every single time. Subtract your 4, x has to be less than 2. Subtract your 4, x has to be greater than -10. So in set builder notation, we go bracket x, and we say, hey, x has to be less than 2, greater than 10. Now this is an overlap. So if I looked at where -10 is, here's where I'm greater than -10. Here's where I'm less than or equal to 2. And so the x's we want are trapped inside that 10 and 2, -10 and 2. And when you write your answer in set builder, you just drop that x in the middle of them because you're trapped inside them, and always point left to the small number, and then always point left to the x. They just always point left as long as this is your small and this is your big. And the reason this works is now your x is literally is caught here. The numbers I want are bigger than the -10, going this way. And at the same time, the numbers I want, they have to stay smaller than the 2 up here. And that's what pins you down in between the two numbers. So there's our graph. And here's our inequality that we'd write, or our set builder notation. It looks like we get to equal the exactly 20 up here, less than or equal to. So these are filled in circles when you graph them. Hope that helps. There's a crummy explanation. Find the area of the circle with that equation right there. Hint, use the area of a circle. Area equals pi r squared. So I need to know my radius. Boom. Remember, x minus h squared plus y minus k squared equals r squared. So my r squared is 15. So I just drop a 15. I don't have to square the 15. The 15 is already the radius squared. Okay. If I wanted to use the formula directly, it'd be like this. Hey, r is the square root of 15. I just had to go boom and boom. And then when I use the formula, you'd end up with this, and you'd square the radical and it'd go away. So we can just skip that step and just jump right to that. And so we can answer 15 pi. Uh, I assume he probably just wants the answer left as that. It doesn't give us units on anything, so it's 15 pi. If you want the decimal approximation, um, 15 times, and look, is good enough to go 3 times times 15 point or 3.14. Okay, but that'd just be an approximation then. All right, hopefully that helps you out with that. Is that everything? Think we got it all? All righty. We'll get this posted ASAP.